All right, Algebra 2 students, we're going to look at a sequential geometric sequence that decreases this time. So I have decrease highlighted here. So here's the problem related to that average male height from earlier. I'm going to say that the males have reached 70 inches tall, and due to drinking too much coffee, they've started to shrink. That's the reason why we're looking at a decrease. And they're shrinking by 2/100%. How tall will the males be in the year 2209 instead of 2009, where we're at right now? And then we're going to take this even a step further about how long will it be until he's 65 inches tall. So, as my wonderful camera assistant backs out, again, when we're setting up this problem, we want to start this out by looking at the initial value. In this one, we're looking at 70 inches for our starting point. And then we're going to go ahead and throw in the multiplier. And again, the multiplier is the one that tells us either that 100% plus the increase or 100% minus the decrease. Because we have 0.02% as our decrease, you want to look at this and say, okay, well, here's 100%. If I subtract 0.02%, then that's going to leave me 99.98%. And again, we've got to think about converting this back into decimal because we can't use a percentage over here. So I'll move that decimal point over 2 places. Now we've got a multiplier. 0.9998, and I ran out of room here. I'm going to get rid of that so I can stick my n up here, so now it looks like that exponential equation. Again, think about that rule where we have a b value bigger than 1, it's going to give us an increase, but as soon as we get a b value less than 1 and greater than 0, that's going to allow us to decrease. So this is saying about 99% of 70 every single year that we're doing this. So the next step we want to do is go ahead and grab out our calculator and plug it in. Not into the function part, but just plug it in. 70 times 0.9998, and then you want to put that little caret with the 200 on there. Stay up on the board there. Thank you. We're going to get this put on your calculator. 70.9998 to the 200. So it's kind of hard to see that sometimes. But as soon as we hit enter, what this is now telling us is after 200, that's what that's giving us. After 200 years, we're going to be approximately 67¼ inches tall. So 67.25 inches is about what we're looking at for the male height if we decrease by 2/100%, starting out at 70 inches over the course of 200 years. To take this one step further, we want to get down to 65 inches, and you'll notice that we're down to 67, so we've only decreased 2 3/4 inches so far at this point. We want to go down another 2 inches, so maybe it takes another 200 years, we don't quite know, but what we're going to do is we're going to go into our calculator. Now we can plug this into a function. Now we put this into the y equals, and then we're going to go to the table to see where we get to 65. So into the calculator we go again. And you can see that I plugged in 70.9998 to the x power. I'm going to hit second graph and go to my table. And you might be scrolling down for a ways because we know that 200 is only at 0.75, so maybe I'm going to do my table set, change that to 400, and let's see what that looks like. So 400 was a little bit too far, so I'm just going to use this to scroll back up, and eventually we're going to get back up to the 65-inch mark, which looks like right about there. So somewhere between 370 and 371 years. Is when our male height is going to get back down to 65 inches. So real quick recap, this number, we don't plug into the table, we don't look at this in the graph, we just plug it into the calculator and let it figure out 0.9998 to the 200th power times 70 to get us this number. However, when we're looking for a specific output value, that's when we go into the graph part of this, plug it into the y equals, go to the table, and then find out which number is going to give us that number. If you have any questions, you know how to get a hold of me.